Now the question is, how do we put multiple step questions together so that we can convert between any of those outer peripheral units without going independently as a step to the mole? So first we have to review and consider what unitary rates or relationships do we have between units that we can use in converting. One, we have Avogadro's number, and I'm hoping by now people know that Avogadro's number represents 6.02 times 10 to the 23. That is a number you'll have to memorize, but even more importantly almost than that number is that you have to understand that that represents a number of objects. I'm going to use the term objects because really it could be atoms, it could be molecules, again it could be Skittles, my favorite, sour Skittles, yum, and those are the objects in 1 mole. Then, as a second relationship, we have molar mass. So this is in grams per mole. Again, per 1 mole, always for now. And these values you get by looking on the periodic table and taking into account the elements in the compound in their relative proportions. Last one is molar volume, and this only works for gases, and we were given a set of conditions which is called standard temperature and pressure, or STP. But you should know what those conditions are, and that is that it's at 0 degrees Celsius, 273 degrees Kelvin, and 101.3 kilopascals of pressure. And for gases at that pressure, there are 22.4 liters of space occupied for every 1 mole of gas. Again, it has to be of gas, and it has to be at standard temperature and pressure. So from those relationships, well, I'm asking you, well, what is common to each of those things? And obviously the answer is the mole. And this is where the mole becomes important, because people think about the mole and I'm like, well, there's 1 mole of this, or there's 5 moles of that, or can you convert between the mass and the mole? But the mole is not ever something that you would be asked to measure. So the real importance of the mole is that it acts as an intermediate between measurable quantities. In other words, it's a cheesy little pun because it'll help you remember, you can think about the mole as being a unit that you can tunnel through to get from the units that you have to the units that you want. What we can do when we're doing these calculations, for those of you that lose track of these individual steps, is to consider drawing yourself a map between the unit that you have and the unit that you're asked to calculate. So the example we're going to look at is that you have 125 atoms of magnesium and you want to calculate the mass. So first off, where's our starting point? Well, we know we have atoms, and in particular we have 125 atoms. And it's asking us for mass. Well, do we know a relationship straight to mass? No, but we do know a relationship to the mole. So to get to the mole, I'm going to draw an X and a line. The unit I'm going from, OM, so this is my from unit. On my map, this is where I'm going from, goes on the bottom, OM. So the atoms go on the bottom. 6.02 times 10 to the 23 objects. Now it's going to the mole. And we know that the mole, as the 2 unit, this is the 2 unit, is going to go on the top, TO. And we also remember that I want you to put a 1, always for now, in front of the mole. So that gets us to the mole. But is that what the question's asking us for? Well, no, so let's keep going on our map. What it's asking us for is the mass. So that means that I need to do another conversion or another step. So I'm going to draw another X and another line. This time my from unit is the mole. The unit I'm going from is the mole, so I'm going to place that on the bottom. And remember, you always for now put a 1 in front of the mole. The unit that I'm going to is grams because it's for mass. The 2 unit goes on the top. And when we look at the relationship between mass and moles, this is our molar mass, and that comes from the periodic table. So for magnesium, the molar mass is 24.31. Putting this in the calculator, I have 125 atoms. Then I would times by 1, but that doesn't change the number, divide by 6.02 times 10 to the 23, and then multiply that answer by 24.31. Do your best to leave that in the calculator as opposed to taking it out and rounding it off and taking it out in the next step and rounding it off, etc., etc. We never worry about our sig figs until our very final answer, because otherwise our result will be skewed by multiple sets of rounding. So when we put this in the calculator, we're going to get 5.05 times 10 to the negative 21. This is important. Be careful, especially if you're using a graphing calculator where it comes up as a capital E in a line of digits, and that unit is grams. So, example number 1. What is the mass of 25.0 liters of carbon dioxide gas? Even though it's not explicitly stated, you can make the assumption that that would be at standard temperature and pressure, STP. So, looking at the solution now, we have 25 liters of carbon dioxide gas. So we're going to do an X and a line to change our unit. The liter unit goes on the bottom so that we can cancel off. And the intermediate unit, the only unit that we know a relationship between liters and, is the mole. Always for now, we're going to go and throw a 1 in front of the mole. And we know that the volume that any gas occupies, 1 mole of any gas occupies, is 22.4 liters. So looking at our units, that means our liters cancel off and we're left with moles. Next step, because this isn't what the question's asking me for, I need to do another X and another line to change my units again. The unit I have right now to get rid of is the mole. So I put that on the bottom. That's the unit I'm trying to get rid of, the unit I'm going from. And I put a 1, always for now, in front of the mole. The unit that I'm going to is for mass, so that's grams. And the connection between grams and moles is your molar mass. For this particular compound, carbon, there's 1 carbon, which weighs 12.01. And there's 2 oxygen, each of which weighs 16. So the mass of the molecule, 1 mole of the molecule, is 44.01 grams. When I put this in the calculator, that should give you 49.1 grams of carbon dioxide. Example number 2. How many molecules are in 45.0 grams of HNO3? Anytime you're given the mass, or any number, remember that's going to be your starting point. So I'm going to start with 45.0 grams. When I look at mass, the only time I need to deal with the mass of this thing is when I see grams or I'm asked for grams. And in this case, I've got grams, so I have to use the molar mass. So I know that there is 1 hydrogen, which weighs 1.01. I know that there's 1 nitrogen, which weighs 14.01. And there's 3 oxygens, which weighs 16. So that means that my mass, my molar mass for this particular molecule is 63.02 grams per mole. So back to my calculation. I've got 45 grams. I need to do an X and a line. Grams goes on the bottom to get rid of it. And I'm going to the mole because that's the unit that I know everything else can relate to. So the mole is going to go on the top. Always for now, you throw a 1 in front of the mole. And 63.02 is what we just calculated as being the molar mass, the connection between the grams and the moles from our periodic table. Looking at my units at this point, notice the grams will cancel off and I have units of moles. That's not what the question's asking me for, so I need to do another X and another line. Next, I have the mole unit right now. So the mole unit is the unit I'm going from, and it needs to go on the bottom. Always for now, the 1 is going to go in front of the mole. Looking back to the question asks for the number of molecules. That's the unit I want to go to. So the molecules unit goes on the top. And the question is, how many molecules, an object, are there in 1 mole? Well, Avogadro's number, 6.02 times 10 to the 23. Putting that in my calculator, I get 4.30 times 10 to the 23 molecules. Don't forget your units in your final answer. Let's go on to example number 3. If you have 4.2 times 10 to the 23 molecules of oxygen, what volume would they occupy? So in this case, we're going to start with the number given to us in the question, 4.2 times 10 to the 23 molecules. And I look at the question and I'm like, okay, well, it's asking for volume. I don't know a single relationship between molecules and volume, but I do know a relationship between molecules and the mole. So I'm going to draw an X and a line, and molecules go on the bottom because that's the unit I'm trying to cancel off or get rid of. The unit I want to go to is the mole, so I'm going to place the mole on the top. Always for now, we throw a 1 in front of the mole, and the question becomes how many molecules, objects, are there in 1 mole? 6.02 times 10 to the 23. Looking back to the question, now we have to look at, well, molecules and molecules will cancel off, and the question's asking me for a volume, which means that I need to go through and change my unit again. So I'm going to draw another X and another line. The unit I have right now to get rid of is the mole, so I'm going to place that on the bottom, and always for now, a 1 goes in front of the mole. Once you have that, I need to look and go, okay, well, I'm trying to get 2 liters. If you have oxygen, which in its natural state is a gas, and we can assume it's at standard temperature and pressure, what volume will that mole of gas occupy? And it's 22.4 liters. Putting that into my calculator, you should get that that gives you 16 liters. Notice there's only 2 sig figs in my starting number, so I should only have 2 sig figs in my final answer. Example number 4. How many atoms are in 27 grams of water molecules? So I start with 27 grams because that's the number that's given to me in the question. And I'm going to draw an X and a line to change my units. The gram will go on the bottom and 1 mole goes on the top. For water, the molar mass is 18.02, which I happen to have memorized because I use it so often, but it comes from the fact that there's 2 hydrogens, which each weigh 1.01, and 1 oxygen, which weighs 16. Make sure you can do that molar mass calculation because otherwise the whole game is going to fall apart before it even gets started. So looking at the units here, we've got grams and grams canceling off, and I have moles. Keep in mind that this is moles of water, which is a molecule because there's more than 1 atom attached together. So next, I'm going to do another unit change, and I'm going to go X and a line. The mole will go on the bottom to get rid of it, and we're going to throw 1 in front of it, always for now. Now, this was the important part from my last statement, was that we have molecules of water, which means that I have to go to molecules, even though the question's asking me for atoms. I know that there are 6.02 times 10 to the 23 objects, molecules, or anything else in a mole. I've got moles canceled off here, and the last thing I have to do is look at how to get rid of the molecule. The molecule is going to go on the bottom, and I know I'm asked for atoms. Not of a specific type, but any kind of atom. So I'm going to place atoms on the top. How many atoms are in 1 water molecule? Well, there's 2 hydrogens and 1 oxygen, meaning that there's 3. Putting that all into my calculator, you should get 2.70 times 10 to the 24 atoms in 27 grams of water. These kinds of questions do require a lot of practice, and so that's why in class you were asked to do a number of practice questions out of your Hebden textbook, and I really encourage you to make the most of the time that you've got and to practice many of these before our test.